Section 5.7 is on solving quadratic inequalities. So quite a bit of the same stuff, except for the equal sign is now going to be an inequality symbol, and we're going to have to do some shading and then decide if the line is going to be dotted or solid. So quadratic inequality in two variables can be written in one of the following forms, where a, b, and c are real numbers and a cannot be 0. Its solution set is a set of ordered pairs in the form of x, y. So underneath here, I have the 4 different ways to write the inequalities. We have is less than and greater than on the top, and then we have less than or equal to or greater than and equal to at the bottom. So the top ones that aren't underlined, so these ones here, those would be dashed parabolas. So you're going to use a dashed line, and that was terrible. And then the bottom ones that are underlined, they include the parabola. So those are going to be solid lines when you draw them. So in order to graph, you have to graph the parabola. Then we have to decide if we're a solid or dashed line, and then shade above if it's greater or below if it's less than. So for example 1, we have to graph y is less than negative 2x squared minus 4x plus 6. So we know that the c value is the y-intercept. So 6 is our y-intercept. Then we have to figure out what negative b over 2a is for our axis of symmetry. So b is already negative 4, so that would become positive 4. And then 2 times a is negative 2 in this case. So we have 4 over negative 4, which is negative 1. So our axis of symmetry is negative 1. Then we're going to plug negative 1 into the equation for x. And solve. So negative 1 squared is 1. 1 times negative 2 would be negative 2. Negative 4 times negative 1 is a positive 4, and then we have plus 6. So 6 and 4 make 10, and then minus 2 is 8. So our vertex is negative 1, 8. So negative 1 up 8, and that is our vertex. And I realized I made a mistake. I graphed that axis of symmetry on positive 1 and not negative 1. So now we have our y-intercept is 1 away from our axis of symmetry. Our other line, our other dot is 1 away on the other side. And looking at our inequality here, it's not underlined, so it's not including the parabola. So we're going to make it a dotted parabola. And then y is less than, so we're going to shade under the parabola, and under the parabola is here. So any ordered pair that's in that shaded region is a solution to that inequality. So for example 2, we're going to solve each inequality by using tables or graphs. And we're also going to use the graphing calculator for this. So we're going to split it up into 2 different problems in our calculator. Y1 is going to be x squared minus 6x plus 8. And y2 is going to be 3. So for you guys at home with the Desmos graphing calculator online, you're going to plug in y equals each one, and your graph would look like this, and you can zoom in and out to look at it. But we are going to want to figure out where our parabola is 3 or under, because our inequality symbol is underlined, so we're including 3. So we want to click the settings, and then we're going to click the little table, and it's going to give us a chart here. And it doesn't give us enough values to see. It starts at 1, but we need to go down until we get to 3 or larger again. So when I click in that X box, I can keep hitting enter, and it will keep giving me more numbers. So as you can see, 1 is 3, and then all the way down to 5 is 3. So we want to know when x squared minus 6x plus 8 is less than or equal to 3. So based on this, smaller than 3 or equal to 3 is anywhere between 1 and 5. So we would write 1 is less than or equal to x, which is less than or equal to 5. So in other words, x has to be between 1 and 5. All right, we're going to do the same thing here with this one. We're going to break it up. Our y1 is going to be x squared minus 6x plus 8, and our y2 is going to be 3. But now we are not including the 3 because our inequality symbol is not underlined, and it's greater than 3. So when is our y1 going to be larger than 3? So we are going to come over here, and our y1 is the same, and so is our y2 is 3. But now we're looking for where they're greater than 3. So it starts at 3 at 1, and as we go smaller with our x values, as we go up the chart, our numbers are getting larger. So they're greater than 3 there, and then they're also greater than 3 at the bottom, starting at 5. So if I hit enter, I can see these numbers are going to get larger and larger, greater than 3. So anything smaller than 1 is going to give us a number greater than 3, and anything larger than 5 is going to give us a number greater than 3, but we're not including 1 and 5. So in this case, we're going to go negative infinity to 1 and 5 to infinity. So we're not including the 1. We're not including the 5 because the parenthesis doesn't include it. Remember, it would be a bracket if it was included. So anything smaller than 1, anything larger than 5 is written like this. The other way is x has to be less than 1 or x has to be greater than 5. And notice those are not underlined inequality symbols because we're not including the 1 and the 5. And then, for example 3, we have to solve this inequality by using algebra. We have to write this in standard form, which means we have to have 0 on the other side. So we're going to subtract 6 from both sides. So we're going to end up with x squared minus 4x, and 1 minus 6 would be negative 5 is greater than 0. And then we're going to factor. What times itself is going to give us negative 5 that adds together to be a negative 4. So that would be a negative 5 and a positive 1. And that is greater than 0. And then now we're going to split these into 2. We have x minus 5, and we're going to change it to equals. X minus 5 equals 0, and we have x plus 1 equals 0 as well. So we're going to add 5. So x equals 5, and then we're going to subtract 1. X equals negative 1. So we have to have anything less than negative 1 and greater and less than 5. That shouldn't be less than 5, greater than 5. So less than negative 1 and greater than 5. And for our last example here, a business offers tours of the Amazon. The profit P that the company earns for X number of tourists can be modeled by this equation. How many people are needed for a profit of at least $5,000? So we're going to break this up into 2 equations. Our y1 is going to be the negative 25x squared plus 1,000x minus 3,000. And our other equation is going to be 5,000. Y equals 5,000. So I take that and I plugged it into the Desmos graphing calculator, and I zoomed in on where they cross. And when I touch on the point where they cross, the x value is about 11.06, and the other one is 28.94. So go back here. We have 11.06 and 28.94. So that means that in order to make at least $5,000, they have to sell over 11. So that would have to be 12 people, and then 28.94 under 28. Not quite to the 29th person. So anywhere in between those two numbers. So I did this using the graphing calculator because Desmos is pretty easy to zoom in and out and around where we need to be. On the graphing calculator is not as easy. So if we're not using a graphing calculator for this, you would want to use the quadratic formula of negative b plus or minus the square root of b squared minus 4ac all over 2a, and you can plug in your numbers, and you will get now the only thing that you would want to do on this would be to subtract 5,000 from both sides so that you had it equal to 0 when you use the quadratic formula. So you would have negative 25x squared plus 1,000x. And then you would subtract the 5,000, so you would have negative 8,000 is equal to 0. And then you can plug that into the Pythagorean theorem, and you would get your 11.06 and your 28.94 again, and still come up with the same answer. So a couple different ways to solve that one.